Example 2, graph one cycle of the function g of x equals 3 cotangent pi fourths x plus pi fourths and then plus 1. So I'm going to rewrite my equation as 3. So that's just a vertical stretch, right? Which in tangent and cotangent is really kind of hard to see. I'll do something to show you what is affected by that. One thing that you can graph to show that stretch. And then we're going to factor out omega, which is pi fourths, so that we have x plus 1, and then we have a plus 1 here. So we have a stretch of 3, vertical stretch of 3. We have omega, which is pi fourths. We have a phase shift, which is left 1. So we could just call that negative 1. That's left. And then we have a vertical shift, up 1. All right, computer. I know you're not happy with me. Get over it. Okay, so let's first focus on omega because that's going to wreak the most havoc here. So omega is pi fourths. So let's take the period and find that. So the period would normally be pi because it's cotangent. So we're going to divide pi by pi fourths, which means we're going to take pi and multiply by 4 over pi, which means the pi's cancel out and the period is just 4 with no pi. That's okay, you just label your graph without pi on the x-axis. It's just going to be labeled in actual numbers instead of weird pi terms of pi numbers. Okay, now let's see what that does to the asymptotes as well. So the asymptotes are normally at integral values of pi. So, like, we would have an asymptote at pi, so we would divide that by pi fourths. So that's going to be at x equals 4, because it'll do the same thing the period did, right? And then, oh, I guess there would be an asymptote at 0, so there's still going to be one at 0. That doesn't change. But then our next asymptote would have been at 2 pi, but now it's going to be at 8. Because 2 pi divided by pi fourths is going to be 8. The pi's cancel out. 4 times 2 is 8, etc. I hope that makes sense. Okay. So let's start putting details in, figuring out how we want to sketch our graph. So notice how I didn't even start sketching the graph until I knew some of these details, because that influences how I'm going to label my graph. So for 4, I could count over 4 and say that that's 4, or I could count by 2s if I wanted to. I think I'll just stick with the grid as is. Let's just count it like it is. So let's say that 4 is here, and 8 would be 1, 2, 3, 4. 8 is there. And 3 is going to be important because we have a stretch of 3, so we're going to see what that does. Then we also have a plus 1 for our midline, so 1 is going to be important, which means that 3 is actually going to move up to 4. And we are interested in that negative 3 as well, but that's also going to move up to a negative 2 value. So many things that are going through my head that I'm not sure you can see ahead that's going to be happening, but maybe you can. So let's do this. We're going to have our asymptotes at 0, and instead of pi and 2 pi, we've discovered it's at 4 and 8, and we could keep going if we wanted to. We have plenty of graph backwards and forwards if we wanted to, but I feel like we're fine just doing one. Well, I was going to say one cycle of the graph, but honestly this is going to be 2 cycles of the graph, but it's what normally would be in 2 pi, so that should make sense. Okay, so then the intercepts would be here at 2 and at 6. However, those are going to be moved up to a new midline right here. So those points will actually be at 2, 1, and 6, 1, right? So we have points. So I'm just going to list a bunch of points that are on this graph as I figure out what they are. So we'll have a point at 2, 1. It would have been 2, 0, but it's moved up 1, so it's 2, 1. And then there's going to be a 1 at 6, 1 that would have been 6, 0 because it's half. The reason I know that they're at 2 and 6 is because they're halfway in between the asymptotes, which are 0, 4, and 8, right? Oh, and I wrote a 0 instead of writing the 1 because I was trying to talk about something else at the time. Okay, so we have those points. Now I wanted to talk about the stretch. So if this graph was still at 0 instead of up 1, then at halfway in between the asymptote and the intercept, so at what's value 1, or would maybe normally be pi fourths, but in this case it's 1, that point for tangent and cotangent is usually 1 or negative 1 because it's sine divided by cosine or cosine divided by sine, and for pi fourths those numbers are the same, so that's where we have 1. So normally we would have a point like right here at pi fourths 1, but because of the 3 in front, that takes that point and stretches it by 3. So besides being stretched by 3, it's also being moved up 1. So that point has both a stretch and a shift in it, so it will be at 1, 4. And then there would normally be a point here at 3, negative 1. However, that's being stretched down to negative 3 and then shifted up 1. So there would be another point there at 3, negative 2. And that is combining both our vertical shift and our vertical stretch, so that we end up with a piece of our cotangent looking like this. So you can sort of see that stretch in there. It's a little skinnier than it would have been. It's going to follow the same pattern between the next set of asymptotes that it did between the first. Once you've got one branch of the graph figured out, you can just kind of copy it from there over and over. So let's just analyze, make sure we've got everything. We've got our stretch of 3 because the point that would have been at 1 has tripled. We've got the period has changed to 4 instead of pi because omega is pi fourths. The asymptotes have squished together. Instead of being at 0 and pi and 2 pi, they're at pi and 4 and 8. And then the entire graph has moved up with midline up 1 and all of the points where they would have been moved up 1.